So today we're talking about the difference of squares, which is another type of polynomial, factoring polynomials. So this is on page 347, I believe, or in that area. So in these first ones, this is an investigation on the idea. We could have done this as a formal one, but we aren't. So a product of negative 16 and a sum of negative 6. So that gives us negative 8, negative 2. We would factor that to be x minus 8 times x, my apologies, plus 2. So our next one, still 16, still negative 16. However, we only want 15, so that means we have to use negative 16 and positive 1. Negative 15 is our b term. So then I factor this to be x minus 16, x plus 1. Next one is a sum of 0. So that means our b time is 0. So we could just short it to be a binomial instead of a trinomial. So in this case, I'm going to have negative 4, positive 4. Negative 4 plus positive 4 gives us 0. 64 equaling 0. So two of the same numbers are going to be 8. One's positive and one's negative. Writing it with a 0 middle term might be helpful as a prompt, but you really don't need to. Our last one is 25, so we're going to have negative 5 and 5. So if you take a second and pause here and look at our last three examples, there's something in common with all three of them. All three of them have our sum of 0. Our products are all perfect squares. And our first terms are just x squared, which also happens to be a perfect square. Our factored form are all a minus sign and a positive sign. Minus sign, positive sign, minus sign, positive sign. So we have some commonalities here, and from those commonalities we can make a general statement. So if I have a perfect square, subtracting a perfect square, my factored form is going to be something like this, with a blank here and a blank here. Those blanks are going to be the square roots of my perfect squares. The workbook explains this a little bit later on, and we'll go through that. So let's try these three examples here. Square root of 9 is 3. So I get x minus 3, x plus 3. Negative 3 plus 3 cancels out. Square root of 49 is 7. Minus 7 plus 7. They cancel out. In these cases, there could be a number in front of the x here, but there's a 1 here, so really those are just 1s there. X minus 6, x plus 6. 1 is a perfect square. We often forget that. So x minus 1, x plus 1. A minus 10, a plus 10. I went through that fairly quickly, so if you need to pause the video and think about it for a little bit longer, please go right ahead. I don't love this next question, so I'm going to skip it. This next one here, explain why b value is 0. So let's go through and expand this general form out. So x times x doing FOIL gives us x squared. Outer terms gives me a positive xy. Middle terms gives me a minus xy. My last term gives me a y squared. So from here, I have a positive xy and a negative xy. They literally will cancel out, leaving me with the two perfect squares. So then on this next one, let's just turn the page. So this is our general statement here, and this is our general formula. A squared minus b squared equals a minus b times a plus b. We've gone through a ton of examples. This next visual aid here, I don't love it. I'm going to bring in hopefully some algebra tiles next week, and we'll be able to talk about this visual a little bit more. Continuing on though past that, let's look at these ones. So again, we have perfect squares separated by perfect squares, specifically a subtraction sign in the middle of them. I want you to pause the video and go through and try these on your own and then check them with me. Okay, so checking over these ones, these should have been fairly straightforward. These types of questions would be like a level 1-2 question. It's pretty straightforward. What's really important and what they highlight at the bottom here for you is it has to be separated by a negative sign. If it's separated by a positive sign, it is not factorable because you can't get a sum of 0 at that point. Okay, turn the page. So now we're going to talk about the fact that our first term could be a perfect square that's not just 1. So for example, okay, so for questions like this, our first perfect square isn't just a 1, like a 1x like we've been doing previously. So for their first example here, the workbook has 4x squared. Well, that a term, or that first term here, is still a perfect square. So the square root of 4 is 2. So we're going to have a 2x minus 5, and then a 2x plus 5. In this second example, I have a 9, which is a perfect square, and a 4, which is a perfect square. So we get 3m minus 2n, 3m plus 2n. Same principles apply as we did before. So let's try some of these perfect squares here. I'm going to do the first couple, and then I want you to try some on your own. So 16 is a perfect square, 49 is a perfect square, so that's 2 checks we get, and they're separated by a subtraction sign, so that's our third check. So this one's going to become 4t minus 7, the square root of each of our constants there, our coefficient, and 4t plus 7. This next one, 81 is a perfect square, and 1. Don't forget that 1 is a perfect square. So I get 9a minus 1 times 9a plus 1. So pause the video and try the next couple on your own, and then press restart and you can see if you got them right or wrong. Okay, so you should see in one of these, this one, e is not factorable because we're separated by addition sign. When we're separated by the addition sign, that makes it so we can't cancel out our middle term to get a 0 for that b. Overall, these ones should have been fairly straightforward. This last one, remember, a times a gives us a squared, b times b gives us b squared. Okay, this next question is a really good question. This would have been a fabulous level 7-8 question. So if you want to try it on your own, I really encourage you to do so. It's really good practice for that level 7-8 unfamiliar. If not, I'm going to go through this one. So an international doubles court. So we're looking at a rectangle. We know the area. We also know that length times width gives us area. So I'm looking for 2 things to multiply to equal our area. Well, that's just factoring. That's the best context we can give for factoring. So in this one, I'm going to get a 5a minus b times a 5a plus b. So let's label this on my little diagram here. So one of them is going to be a length, and one of them is going to be our width. So now where the real 7-8 comes in is question B. So the perimeter of our floor is 140 feet. Determine the length and the width if the length is 1.8 times the width. So we are given 2 pieces of information here. Let's start with the first sentence. That's usually helpful. Let's start with our perimeter. So perimeter is 140, which means we have 2 lengths and 2 widths to equal that. Well, above, we just labeled what our length and width was. So let's fill that in. So from here, let's clean this up. Let's simplify. Let's combine our like terms. Let's take it a step further. So remember, in algebra, you do not know the ability to solve when there's 2 variables. So likely, we're going to give you questions where there's no longer 2 variables. And that's exactly what happens here. 2b, positive 2b and minus 2b, those cancel out. So we don't have to worry about our b's. 10 a's and 10 more a's give us 20 a's. Divide both sides by 20, and we've solved for a, which means we're at a good start to being able to figure out an actual number for our length and our width. Okay, great. We're halfway there. We used our first sentence. Now can we use our second sentence to help us figure out that width? The length is equal to 1.8 times our width. Okay, so we have a starting formula just like we did over here. Can I now use that formula and plug other things in to isolate and solve for b? Well, my length we know is 5a plus b, and our width we know is 5a minus b. Okay, so let's go through this and let's expand this out. 1.8 times 5, I don't expect you to know right off your head. You should have the ability to multiply that out though. So you can do your long multiplication. Remember this unit, we don't have calculators, so 1.8 times 5 is just 9. So from here, I want to combine like terms. So let's move our 5a's over. Those cancel. I'm left with a b. 4a minus 1.8b. Add 1.8b to both sides. So I get 4a equals 2.8b. We know that a from earlier is equal to 7, so I'm going to plug that 7 in. Save space, we know 4 times 7 gives us 28. Isolate b, so then b is equal to 10. We're not done, and this is a really important piece. Often we forget that we're not done, so from here we actually have to plug it in. So I'm going to go 5a times 7 plus 10, and then 5 times 7 minus 10. So I get 35 plus 10, so I get 45 feet for our length. 35 minus 10 gives us 25 feet for our width. So a lot of components to this question. Really good problem solving here. A really good question right there. Okay, our very last piece of this is we can include greatest common factor. So we keep going back to that each time. So when you have a greatest common factor, we always want to take it out first. Whenever you have a value in front of your variable squared term, so in front of our first term, you always should think first, is it the greatest common factor? So in this first one, I can take out a 2. And now I'm left with a difference of squares. So now I can factor this further. Your final answer is always your fully factored version. Second example, I can factor out the 3. And so on. And that's it. So remember our next class, so on Tuesday we're starting class with a quiz. That quiz will include lessons 1 to 5. It's actually going to be a leveled quiz with a maximum of a level 4. I haven't taught you anything yet that's further than that. So we're maxing out on a 4. That's going to be the beginning of class on Tuesday. Here's the practice questions I would suggest you do over the weekend. And that's it.